Hey, this is Joshua Blackman, and I'm about to show you how gravity works. And it's not really just gravity, but I'm going to show you the hidden factor that a lot of people miss. So what's wrong with this statement? M equals G. What's wrong with that statement? You're missing a factor. You're missing a huge factor. Think of that. What's that statement mean? If with a 1. That's mass equals gravity over what? Magnetic field. Mass equals gravity, but mass also equals magnetic field. They're contrary to each other. Imagine if I have two little balls. Alright, one's going this way, the other's going this way. So what happens when this one starts spinning this way? This one spins this way. Contrary to each other. One's positive, one's negative. But not in the sense like an electron and a proton. One's positive, one's negative. Why? One spins right, one spins left. That's the only what positive and negative mean generally when you get deep into science. So what happens when things get huge? Alright? Things get huge. And I have the math for all these little planets too. Let's say you had a sun. The sun would spin left. Contrary to that, the earth would spin right. That's all that would happen without gravity. It wouldn't orbit yet. But once gravity hits, what gravity does is this little thing goes into that little thing and gets destroyed. But what else happens is because of magnetic fields, it orbits instead it gets destroyed. So just because they're contrary to each other with magnetic fields, and they would just spin because of gravity, they orbit. So magnetic field, that's M1 plus gravity, that's plus gravity equals mass in a sense. So that's actually reversed. Capital M equals M1 magnetic field plus gravity, or over gravity. So how you would find the magnetic field, it would be part of that mass or that magnet or that gravity. So what happens is one object spins right, one object spins left, and the gravity causes it to orbit. So in majority of the time, it's one object that's bigger than the other object. Let's say the Earth and the Moon. The Moon spins right, and if you notice that the Moon spins opposite of the Earth, this would make sense to you. Moon spins opposite, slowly but surely. Earth's magnetic field causes it to go along, and if you notice that it does actually follow our axis, and that kind of, and let's say this was Mercury and this is Earth, and this is spinning this way, and because of gravity it wants to orbit, and they all have the same orbit. So this is how you know that the sun spins the opposite way and everything else spins the other way. Otherwise everything would spin a certain way. And axes, this is a different story, but right now we're just working on magnetic fields and gravity. Remember, gravity would mean this would be destroyed, but because of the magnetic field it spins, and because of gravity it orbits. So gravity plus magnetic field equals orbit. That's also what it equals. So they're contrary to each other. Very easy. Very easy subject, and I'm about to prove that math that shows this, a simple math that shows this true. And also closeness has to do with it. Why? Because think about it. You get one big ball, you got a little ball right next to it. What happens to that little ball? It spins faster and faster and faster and faster, and even orbits faster because this thing is so close. Now if it was very far away, that would be a different story. Like that would be like if this little thing was like this, and then it had all kinds of gears on it, and the little ball was right over here, it would be a different story. But since it's so close, like Mercury, it goes very, very fast. Closeness is another factor, but I haven't figured out how to get closeness into that factor, into a mathematical factor. But I got gravity and magnetic field, which is the most important part. Now, Mercury equals 100K mph. Mercury's 100K mph. Hold on. Give me a second. Going to the light. Okay, Mercury's 100K mph. It's 100 miles per hour, and it's been proven. Jupiter is 30K. Can you guess what the Earth is? You think it'd be somewhere in between this, wouldn't you? No, it wouldn't. Obviously, because the math shows that mass and closeness have to do with it. So the Earth is 3 times far away. So you think it'd be a third the speed. But then again, you forgot mass. You forgot mass and magnetic field. It's half the density. I mean, it's twice the it's not twice. It's twice the mass. And it's 3 times far away. And the further you get away from something, it's not just like 3 times means a third. Obviously, Jupiter is a third, and it's 5 times farther away than Earth. So it has to do with how badly the magnetic field affect each other. Remember, there's magnetic waves, and they cross each other. The further you get, the less magnetic waves cross each other. So the Earth, likewise, would have 7,891 mph. Earth has 7,891 mph. And that makes you wonder, well, Jupiter's so far away. Why does it, like I added closeness is another reason. Why does it have 30K? Well, think of the mass. The mass is 2.5 times bigger than all the planets in the solar system. Closeness definitely matters here, but mass matters more. Sometimes. And as you can see, that sometimes is a big sometimes. It has to do with the smaller object. Also, Earth is a bigger object. Mercury is a smaller object. Smaller objects tend to go faster unless they have a huge magnetic field, which Jupiter does. Jupiter's magnetic field reaches past Earth. That's why Jupiter goes faster than the Earth. Magnetic fields touch each other. So, you got Jupiter, which is huge. Magnetic field going right. You got the Sun going left. And that magnetic field alone causes this spin. Jupiter's speed is 16-hour days, which is very, 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 very fast since the Earth is only 24-hour days. That tells you how weak the Earth's magnetic field is. 24-hour days, and the Earth is much, 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 much smaller. And a little spot on Jupiter is 20 times Earth. And it probably does that in an hour. So, the Jupiter takes on Earth's days in 1 hour, and Jupiter's much, much bigger, which is ridiculous. And then once you take in mass and gravity, you get this spin. I mean, you get this orbit, obviously. And then Jupiter's mass is 318 times bigger than Earth. 318 times bigger than Earth, which is a huge mass. And that's not saying 7 times 318 equals 30. No, that doesn't equal the same thing. What comes out is that the rate of the magnetic field and the rate of gravity, which this comes out to over a rate. It has to come out to a rate equals orbit. the rate of gravity and the rate of magnetic field equals orbit. In a certain rate, it might even be gravity squared. It's more than likely magnetic field squared, because magnetic field seems to be stronger than gravity. The reason why we're on the Earth is because of gravity. If it wasn't for gravity, we'd be flying off the Earth regardless of magnetic field. But then, since there's a small amount of gravity, we stay on the Earth. We don't get crushed. Like people assume, oh, it's all about gravity. No, the magnetic field, again, makes people think there's so much gravity. But the magnetic field, it's really magnetic field over gravity, which equals mass, which equals orbit. Magnetic field over gravity equals mass equals orbit. Don't you see the equation? And what Einstein was missing was magnetic field. That's why when you look at the universe, the galaxy, just a galaxy, and it's spinning this way, ironically, which the black hole would have to be spinning this way. So everything is contrary, spinning this way, because they have opposites. No, everything can spin with the black hole because of the gravity. But everything in there has to spin opposite of the black hole. Alright. So if you notice that that's a big factor, it's magnetic field, obviously. So you have two balls. One spins left, one spins right, and they're contrary. And that's only if they're even. Gravity does. Let's say you didn't have a magnetic field. Let's say you had a dot, and let's say that dot was a supermassive black hole, and let's say you had something the size of a sun. Without the magnetic field, it would just go straight to that black hole, which is a dot, because of all the gravity built up in that black hole. Now, because of this magnetic field going this way, contrary to this going this way, and it has waves, so it continuously goes this way, and it's a continual pattern, and that's where the math comes in, because it's not just one big, oh, it's going left. No, it's going left in waves, and this is going right in waves. That's what happens. These magnetic fields interact, and they cause each other to spin. That's like two magnets coming together, but spinning. If they were spinning, they wouldn't touch. If they were spinning fast enough, they wouldn't touch. They couldn't touch. The only reason they do touch is because of gravity when they spin. And that's because they're too close together. Now, if they were far away, they could affect each other. If you had two balls that were both magnets, north and south, doesn't matter, they're spinning, you just created one negative, one positive, and one negative. You just created a positive and a negative, because the two different spins are positive and negative. And you know that positive is attracted to negative. But with a spin, they only affect each other by their magnetic fields rather than directly. Now, otherwise we'd be heated up by the sun. And as you can see, we're not. We're heated up by the magnetic fields. Say this is the sun, this is the earth. The magnetic field of the earth is rubbing on probably the first or second layer. Probably the third layer. If we counted it by planets, it'd be the third layer of the magnetic field. And that's why Jupiter doesn't go as fast as you would think. Jupiter only goes 30 miles per hour, 30,000 miles per hour, which is much faster than the Earth, but it's further away, so the magnetic field doesn't affect it as much. Now, the magnetic fields affect Mercury to the point where it has to go really fast, because that's the initial magnetic field. This is the second magnetic field, which is Venus. This is Earth, which is affected by a less stronger magnetic field. But because of the massness of Jupiter's initial magnetic field, Jupiter's secondary magnetic field, Jupiter's third-degree magnetic field causes it to spin fastly and abruptly, and because of its massness, orbit causes it to go around the sun. Let's say this is the sun. Of course, Jupiter's much, much smaller than the sun, but because of its massness, and because of its massness and because of its magnetic field, it goes around the sun much more. Easy and simple. Easy as that.